So let's talk about a major breakthrough. We're not just talking about an AI that solves problems anymore. We're talking about an AI that's actually designing the next generation of AI. And, this isn't just hype. A new research paper dropped this bombshell of a quote, and it really hints at a massive shift. Researchers are even calling it an AlphaGo moment for AI design itself. And that really gets to the core of it, right? I mean, what happens when the very thing we're trying to improve starts improving itself? This question, it gets at this massive bottleneck that's been slowing down tech for a while now. And it's exactly what this new research is designed to smash through. Okay, so let's dig into that. What is the core problem here? Well, it's this fundamental paradox that has basically put a speed limit on how fast we can innovate. And here's that paradox in a nutshell. On one hand, you've got AI capabilities just exploding, right? Growing exponentially, like a rocket ship. But on the other hand, the actual research, the process of creating these new AIs, it's still stuck moving at a human pace. Our own brain power has become the bottleneck. So you can see the problem. To break through this wall, researchers had a pretty radical idea. They decided to build a whole new kind of system, not just a tool, but something that actually thinks like a scientist. And here it is. It's called ASI Arch, which is short for Artificial Superintelligence for AI Research. Pretty cool name, right? And its whole purpose is to automate from top to bottom the entire scientific process of finding brand new AI architecture. Now, this is a huge shift in how we think about this stuff. Older methods were kind of like being a chef. You have a pantry with a fixed set of ingredients, and your job is to find the best combination. But you can't invent a new spice. AI Arch, it doesn't just optimize what's already there. It autonomously dreams up, codes, and tests entirely new concepts. New spices, if you will. Okay, so how in the world does an AI actually do science? It's a fascinating process, and it works a little something like this. So you can picture the whole system as this tireless, automated research lab. It's built on a team of different AI agents, and they're all locked in this constant, closed loop of discovery and then refinement. It never sleeps. Yeah, think of it as a little AI research team with 3 key players. First up, you've got the researcher. This is the creative one, the one that dreams up all the new ideas and designs. Then you've got the engineer. It takes that idea, writes the code, and runs all the experiments. And finally, the analyst comes in. It crunches all the numbers, learns from every single success and every failure, all to make the next idea that much smarter. So where does all this knowledge come from? Well, it learns in 2 really cool ways. First, from its own direct experience, learning from the thousands of experiments it's running. But it's also, and this is brilliant, standing on the shoulders of giants. It has what's called a cognition base, which is basically the collective wisdom from almost 100 of the most important AI research papers ever written by humans. All right, so they've built this thing. The system is in place. And the researchers basically just set their AI scientists loose on the problem of designing a better AI. What happened next? Well, the results were pretty staggering. So, just how much work are we talking about here? Over the course of this project, this single AI system independently conducted over 1,700 unique experiments. And that translates to an absolutely staggering 20,000 GPU hours. I mean, to put that in perspective, that's more than 2 straight years of nonstop, focused computational thinking. And look at this. Through all that thinking, ASE Arch generated this incredible family tree of completely new AI designs. Every single branch and node you see here is a unique architecture it came up with, tested, and then learned from. It was exploring these design pathways that human researchers hadn't even thought to look at. But here's the kicker. This wasn't just about throwing stuff at the wall to see what sticks. Out of all that exploration, it discovered over 100 brand new architectures that now qualify as state-of-the-art. And a lot of these use design principles that were totally counterintuitive, things human experts might have dismissed. And of course, the proof is in the pudding. When you put these models to the test on standard industry benchmarks, what happened? The models discovered by the AI consistently and significantly outperformed the powerful models designed by top human experts. The student had officially become the master. But the biggest discovery here wasn't any single new AI model.
It was something way more fundamental. It was a whole new principle for how scientific discovery itself can actually work.
The team was actually able to establish what they're calling the first ever empirical scaling law for scientific discovery. And this is the real game changer. I mean, think about it. For all of human history, scientific progress has been tied to human ingenuity, right? To our intuition or genius. This research establishes a brand new law. For the first time, scientific discovery in this field is no longer limited by human brainpower. It now scales with available computation. That changes, well, pretty much everything. It completely reframes scientific discovery, at least in this domain. It's no longer a scarce resource limited by humans. It's now a scalable industrial process. You want more breakthroughs? Just add more GPUs. It's a wild idea. Okay, so let's zoom out. Where do we go from here? What does all this really mean for the future of AI? What we have now is a clear blueprint for a self-accelerating feedback loop. It's pretty straightforward. An AI designs a more powerful and efficient AI. That new, better AI can then be used to speed up the research process itself, which in turn leads to the creation of an even better AI designer. And you can see how this cycle just repeats, getting faster and faster each time. And that leaves us with this really provocative final thought to chew on. For the very first time, we have actual empirical evidence of a system that can improve itself. It creates this clear pathway to a future where the pace of innovation is no longer set by us, by humans, but by the tireless exponential speed of AI itself. What does that world look like?